Welcome to another trig substitution example. In this case, we are going to evaluate the definite integral from 0 to 1 of x squared over the square root of x squared plus 6x plus 10 dx. So in this case, again, we're going to deal with completing the square first for our square root. So if we complete the square first, that x squared plus 6x plus 10 is equal to x squared plus 6x plus blank plus 10 minus blank to balance out what we're adding in. To find that blank, we take our plus 6, we divide it by 2 to get 3. And then we square it to get a plus 9, and we'll minus off 9 to balance it out. So we are looking at x plus 3 squared is our x squared plus 6x plus 9, and then we have a plus 1 on the end. So we are taking the definite integral from 0 to 1 of x squared over the square root of x squared plus 6x plus 10 dx. And this is the exact same thing as taking the definite integral from 0 to 1 of x squared over the square root of x plus 3 squared plus 1 dx. At this stage, we can do some u substitution. We'll go ahead and set u equal to x plus 3. Then we have our du as just dx. We might as well convert the bounds as well. So converting the bounds. X equals 1 would mean that u is equal to 1 plus 3, otherwise known as 4. X equals 0 would mean that u is equal to 0 plus 3, otherwise known as 3. And so we are working with a definite integral from 3 to 4 of x squared over the square root of x plus 3 is now u squared plus 1. Dx is du. Our x would be the same as u minus 3. Let me make that so you can see. So x would be u minus 3. So we'll replace that x squared with a u minus 3 in parentheses squared. So we are looking at the definite integral from 3 to 4 of u minus 3 in parentheses squared divided by the square root of u squared plus 1 du. At this point, we have a u squared plus 1, so that square root will be our hypotenuse. We can go ahead and draw our triangle. Again, our hypotenuse is the square root of u squared plus 1. 1 is just 1 squared, so we will put 1 as the adjacent, u as the opposite. The u and the 1 give us the relationship that tangent of theta is equal to u over 1, or u is equal to tangent of theta. That means that du is secant squared theta, d theta, using our square root u squared plus 1 and the 1. That relationship is secant theta. So we have secant of theta is the square root of u squared plus 1 all over 1, otherwise known as the square root of u squared plus 1 is equal to secant of theta. So plugging in, substituting in, we had definite integral from 0 to 1 of x squared over square root x squared plus 6x plus 10 dx. That was equal to the definite integral from 3 to 4 of u minus 3 in parentheses squared over the square root of u squared plus 1 du. This is equal to, I'm going to leave question marks for my bounds for now, a definite integral from something to something of u was tangent theta. So we have tangent theta minus 3 whole thing squared over square root u squared plus 1 is secant theta. So all divided by secant of theta. Then our d theta was, our du is secant squared theta d theta. So we end with multiplying by secant squared theta d theta. So first finding the antiderivative. We are looking at an integral of one of the secants cancels out. So we have tangent theta minus 3, that whole thing squared, times secant of theta d theta. This becomes an integral of tangent squared theta minus 6 tangent theta plus 9 all times secant of theta d theta. We can go ahead and split this into 3 integrals. This is equal to the integral of tan squared theta times secant of theta d theta minus 6 times the integral of tangent of theta secant theta d theta plus 9 times the integral of secant theta d theta. We know the integral of secant, tan theta secant theta is just the derivative of secant, so we know that integral. So the only thing that we really have to figure out is that tan squared secant theta d theta. But tangent squared theta is just secant squared theta minus 1. So we can rewrite this as the integral of secant squared theta minus 1 all times secant of theta d theta. And we have minus 6 times integral of tangent theta secant theta is just secant of theta. And then we have plus 9 times the integral of secant of theta is natural log of the absolute value of secant theta plus tangent theta. I'm going to just throw a plus c on the end here. That first integral we can now split. This is the integral of secant cubed of theta d theta minus the integral of secant theta d theta minus 6 secant theta plus 9 times the natural log of the absolute value of secant of theta plus tangent of theta. and the parentheses, and then plus c. Integral of secant cubed we already found in a previous video. Integral of secant cubed was 1/2 secant theta tangent theta plus 1/2 times the natural log of the absolute value of secant theta plus tangent of theta. Then we have minus the natural log of the absolute value of secant of theta plus tangent of theta. And we have our minus 6 secant of theta plus 9 times the natural log of the absolute value of secant of theta. So I apologize, I need to update my screen. All right, so the line we're on now, we should have it, our antiderivative is equal to 1/2 times secant theta tan theta plus 1/2 times the natural log of secant theta plus tangent of theta minus the natural log of secant theta plus tan theta minus 6 times secant of theta plus 9 times the natural log of secant of theta plus tangent of theta. And then we have plus c. This we can go ahead and simplify. We have a 1/2 secant theta tan theta we have a plus 1/2 the natural log of secant theta plus tan theta. And we have minus the natural log of that, so that becomes minus 1/2. Then we have plus 9 times that same natural log. So we have plus 17/2 the natural log of secant of theta plus tangent of theta. Then we have our minus 6 secant theta, and then plus c. Converting back to u, so plugging in our secant of theta was equal to, I apologize for all this scrolling. Secant of theta was the square root of u squared plus 1. Tangent of theta was just u. So secant of theta is the square root of u squared plus 1. Tangent of theta was simply u. So we are looking at 1/2 times the square root of u squared plus 1 times u plus 17/2 of the natural log of the absolute value of the square root of u squared plus 1 plus u minus 6 times secant theta, so minus 6 times the square root of u squared plus 1, and then plus c. From here, we need to find the definite integral. So we were looking at the integral from, for u's, it became the integral from 3 to 4. So we were looking at the integral from 3 to 4 of, we had u minus 3 squared over the square root of u squared plus 1 du. This is equal to that whole mess we just found. So 1/2 u times the square root of u squared plus 1 plus 17/2 times the natural log of the absolute value of the square root of u squared plus 1 plus u minus 6 times the square root of u squared plus 1, all evaluated from 3 to 4. So we are looking at 1/2 times 4 times the square root of 4 squared plus 1 plus 17/2 times the natural log of the square root of 4 squared plus 1 plus 4 minus 6 times the square root of 4 squared plus 1. From that, we are subtracting off 1/2 times 3 times the square root of 3 squared plus 1 plus 17/2 times the natural log of the square root of 3 squared plus 1 plus 3 minus 6 times the square root of 3 squared plus 1. This becomes 2 times the square root of 17 plus 17/2 times the natural log of 4 plus the square root of 17 minus 6 times the square root of 17 minus, in parentheses, 3/2 times the square root of 10 plus 17/2 times 3 times the natural log of 3 plus the square root of 10 minus 6 root 10. And we can simplify it further if we like. But you get the general idea. So this is how we can go about finding, doing trig substitution involving some use substitution as well, and taking a definite integral. In the next videos, we will move on to a new section in which we will use partial fractions to evaluate integrals involving rational functions.